Welcome back everyone to the third session of the two-day conference on quantum physics, brain function in modern science and Buddhist philosophy. The theme for the third session is non-locality and individuation in quantum physics, Buddhist philosophy and neuroscience. Professor Partha Ghosh, Honorary Scientist, National Academy of Science, will be the chairperson for the session. And we have Professor Barendra Malik, Department of Neurobiology, JNU, Ms. Pooja Dabral, Assistant Professor, Department of Buddhist Studies and Tibetan Studies in Namgyal Institute of Tibetology, Gangtok, and Dr. Anil Choji, Associate Professor, Indian Institute of Science, Education and Research, Kerala. Now may I request the chairperson and the speakers to sit on the dais. So without wasting much time, I would like to hand over the session to the chairperson, Professor Partha Ghosh. Yeah.
Good afternoon. Good afternoon, everyone. So we will begin this session now. There are three speakers, Professor B.N. Malik, Ms. Pooja Dabral, and Dr. Anil Choji. You will all have 20 minutes. Professor Malik is a gold medalist in college. After completing his PhD at AIMS, he preferred joining the School of Life Sciences in JNU as assistant professor, and since 2001, he continues there as a professor of neurobiology. He holds several positions as member chair of several national and university level committees, including Dean of the SLS/JNU during 2013-2014. He teaches several courses to the MSc, MPhil, PhD students. Starting from scratch, he has established a neurobiology research lab in general and REM sleep research in particular in JNU. Research on REM sleep in particular was started by him in this country. His research focuses on understanding neural regulation and functions of REM sleep. Because of his academic contributions, Viren Malik has been elected fellows of all the three nationally recognized science academies. He has received several national awards and recognitions, including J.C. Bose National Fellowship, S.S. Bhatnagar Award, National Biosciences Award, and Shakuntala Amir Chand Award, to name only a few. Professor Malik.
Okay, friends, good evening, and thanks to the chair and thanks to the organizer to invite me here. It's a very difficult topic that I will be talking. Basically, as you have heard, that I am a neurobiologist as an experimentalist. The link here is I work on neurobiology of the mechanism of REM sleep, the sleep on which one dreams. But I work on the neural mechanism, how and why it happens and why the disorder. And you have heard many lectures since morning, and they are very, very informative. And what I will try to speak from my neurobiology background, what this consciousness could mean, and then how that deviation would cause the normalcy or the abnormal physiological states. That is why I have given this definition. But you can imagine all these so-called complex things which or any of us is trying to understand, be it from any background of knowledge, and that is by this brain, and we are going to try to understand that brain. I mean, it's a paradox. Can I see the world by sitting on the earth? I have to go up to see the whole world. And in other words, I have to model a system if I have to see. Can any of us see our own eyes? But we look through the eyes. So this is a paradox. What I mean by it, when we try to understand anything, we have to first define what we are trying to understand. And next it comes, even after definition, the understanding depends on our personal knowledge. It's so difficult to make a child understand 2 plus 2 equal to 4. But the same child, after a few trials, goes for another. And I am trying to understand what happens in the brain when it becomes 2 plus 2, 4. So what we try to do in a sense, try to have an understanding and the structure function correlation. And since the time is very short, this about 18-20 minutes at my disposal, and with this type of complex audience, I'm summarizing what I will be trying to talk about. What I will say, the knowledge evolves, and how do we try to understand in the brain? That is in the brain, for the brain, by the brain, neurons have evolved because that has the action potential, that has the discrete unit form which carries information. But if the information has to be carried, it cannot be carried in space. It needs a medium. That medium is the consciousness. And that is by the glia. And essentially, I will try to give you that, and then we can discuss anything. This is what I said. We understand by logic, which depends on support from, and that depends on what it matches. And the moment we talk about matches, that is discrete value. If we say 4 has a discrete value, matches with 4, 4.1, 3.99 would not. Now it depends on what is the flexibility, what is the variation or standard deviation, how much we can allow. Every system will have a deviation. Otherwise, a system is dead. That is how we go even in biology. Once it is there, some of the fundamental principles, the most complex, are consciousness, thought, self. And then consciousness, the way it has been many ways to define, the way I have understood and what it is, say one way is regarded as a complex qualities such as subjectivity, self, and many ways it has been talked about. How is it happening? Evolutionary, if we talk about what is happening, from Big Bang, the way we understand, we have got into human or any life system, that is what is shown here. So if we talk about self-awareness vis-a-vis relative to other system, well, this also is something vis-a-vis with something. Does it have consciousness? Theoretically, it should. But I am defining for my talk, we are talking about for a living system. That too we are talking about where we understand. That is in a higher system. Now, does it mean it may or may not be there? That is my ignorance. I should not thrust my ignorance on anybody else, particularly throughout the world. Quite often when we do not understand, we thrust the responsibility, it is vague. That is my irresponsible way to say that, okay, you don't understand. This is where I understand. If that is there, consciousness states, generally we talk about wake, sleep, and then we talk about REM sleep. If we behave this way, or if you can put it, the ant which moves and then stops sometimes. This is again in my lab. Then I can talk about here, the fish. I'm going gradually because I am an experimentalist. It goes in different ways. See, it stops here, this one here. So we say that is immobile, so probably sleep or not. Then we talk about here, any species. Now, how do you know particularly if I talk about this, who would dare to go there and touch? Even if I say one is sleeping? Means what? We know these happens. Means what? We need some objective criteria to understand. Knowingly, unknowingly, we all go by objective criteria. That is what is understanding. And the fundamental of it, mathematics or the number crunching, that is the basics of language. Before that comes concept, that is philosophy. And if that, I'm sorry, it has come here. I don't know how did, okay, here. So we understood this when we tried to understand the electrical signaling in the brain. And these are electrical signaling in different animal species, including, and here you will find in the humans, this is what it is, EEG. At least the way we can understand why it is. Based on that, my lab worked and we worked out how different neurons are connected and going into for the regulation of REM sleep with different neurotransmitters, subtypes of receptors. This is required even for your disease amelioration and all. And ultimately, you will find this is the latest model, latest was published in 2012. That is the latest model for understanding worldwide. This is how the REM sleep is occurring. What we understand, that is has come from this lab. We have done this mathematical modeling again to understand for other things, which I am not going to speak here. Okay, what happens during this wake stage? Say certain of the neurons are active, not all. This has a reference later, I will speak. During then sleep, see these are not active or very little active. And during REM sleep here, see these are very active, these are shut off. Means what? Bottom line, even if we have billions of neurons, they're not active all the time. They're active at certain points, less active, more active, and they shut off during. This is how it works in the brain. So this will have a relevance. Now what happens in all over the body? If it is there, this movie will show you, just to have a look at for a few seconds. This is again in my lab. See, from two-stage, I will come to how a zebrafish grows. And that is how all of us have grown in our mother's womb. And you will gradually see how it is going into 3 months, 6 months zebrafish, and then we will work on it. Similarly, we'll work with any system, including humans. So if that is there, why it's a concept of consciousness about brain only? That means there has to be a specialized class of neurons. So this is how I think 10 days old, then it will go zebrafish going and you can work it. Just to show you that yes, you can do things in the lab. I don't say that it is just bakwas. So we can do things, and we have recorded electrical signaling from these zebrafish brain as well, which I am not showing. Okay. Then the challenges are, what would be the basic principle and how to study consciousness? The problem is the definition there. Once we can define, then probably we can understand, or we can attempt to understand. That also would depend on development of the system, instrumentation, and all those. And therefore, top scientists from every field, neuroscience, biology, psychology, physics, you name, they have all jumped into to understand consciousness. Now, experimentalists like me, we are trying to understand the structure function basis. I said it is primarily because of the brain, by the brain. So what is the structure-function relationship? This is how the brain is, where this is with neuron, and it has this electrical signaling. Now, the electrical signaling, this one, is a discrete value within a millisecond. Now, on what it will work on it? They have a transmembrane DC potential. On the top of it, this works. So if that we saw, and we talked about EEG. Now, if we talk about only the brain, can we isolate the brain and keep it? Will it have consciousness? This is my work, which is known as encephalo-isolate preparation, of course in cat, not that I had created. This was first done by Bremen, 1935. And today's world, probably I am still a living person who has maximally done this way. Of course, my PhD work. You cut the spinal cord here, so only the brain is there, and of course neural connection in the brain. You have the EEGs here, and they spontaneously change from synchronization and desynchronization. With a more of jargon words, don't have to worry about it, but still you have EEG changes if you can maintain the blood circulation. And nowadays even we do neuronal culture. I will not have time to show, and there also you can get electrical signaling. So if that we saw, then what are we talking about? And this is what EEG whole animals. In this, if we get this is reticular formation, and this, if you stimulate, you get EEG like this. And these EEG, if you do empirical mode decomposition, you can decompose into these 10 waves. What are these waves? Change. Whenever we have wave patterns, there are frequencies and voltages. So this is what you can. So you can say here higher frequencies to very low frequency it is there. That is here in the brain, because there are billions of neurons that they are firing a different pattern. I showed you how do they fire, and that we define this is wake state or awake state or sleep state or REM sleep state. And then we can say, oh, today I'm not feeling that way. I'm feeling not sick, but sickly. What does it mean? Because we have some, that meaning may have something for me, something for you. These are vague definitions. That is how it differs here. We can define by these EEG changes, and we can modulate these by modulating receptors and neurotransmitters and all these, and we have done it in the lab. Now, if that is there, what are these waves? They're signal form. So what did I say? Consciousness, the way we are defining orientation or 5 minutes, right? Yeah. Orientation or information about self with reference to others. Means if this is the reference with me, how do I do this? This should get the information from me, then I should get the information about it. Now, in order to get the information, something has to travel to me. How will it travel? Either this molecule has to move on me, otherwise a wave pattern has to come. See, here there is a wave pattern, that is a brain wave. Wave is not there for liver. It's not there for kidney. So that is how it is in the brain, which is for the brain, by the brain, of the brain. Once that part is there, this is what the wave pattern is coming. Whatever may be the system somewhere. If these systems are so complex, electrically there are noise embedded into the system which has to be filtered or eliminated. There are frequency responses, there are impedance matching, and there is resonance. So what we have to do is, and generally that is what is done, which we know or we do not understand. We filter off the thing in the brain, probably meditation and others, that is what people are trying to do. If we are doing in a single, either by eliminating others, or we try to average it out to make one. What either of them I do not know. First thing has to be hypothesis. So once that is there, then when it comes here to either the impedance matching is such that it can gather the information, and then one would know what is its relevance and which reference. Now, if we have to do that, we are talking about modern science. Does it have any correlation to explain this? We have this additional Upanishadic view, which is Turiya. Now, what I thought, the Turiya state is there, all-inclusive surrounding. When this comes up with a strong input from reticular formation because of peripheral inputs, we are calling it wake, because I showed you the other neurons are active. And when other neurons are active, it becomes non-REM sleep, and when other neurons are active, it becomes REM sleep. That means this keeps on going at the background. Turiya is there. Now, if that is there, is it the neuron and others are happening? So this is what I said. This is masking and unmasking of expressions defines different states, and that is where is the normal state or different disorder that we get. Then we talk about these neurons, and we have cultured, we have found even in the lab. See, this is a bookish picture, how many synapses they form, and here is the primary culture in the lab, and here, see, these are thousands of synapses they are getting formed, which I will not talk about. Now, the final last two slides, in addition to the neurons, as I said, what is the medium on which the neuron will work? See, the glia to neuron ratio, glia essentially starts from here about snail or so Drosophila. And this is better here. First, the neuron has started in evolution here. Then the red one here, neurons and glia from here, which is your asylum for here. And if this is the complexity of the brain starts, and generally we talk about consciousness from here. And here, this is how the glial waves are very low frequency there for long distance. And once this is very low frequency waves are there, that is probably because it is low frequency. Whenever we talk about frequency, that is containing the information. So if it has points, say 50 and then 1 versus 1 hertz, 1 hertz goes like this, where the information is contained there, here the information is there, and that is a non-local behavior. And that is the non-local behavior, the consciousness on which the neuronal activity works to give the local behavior, that is different states, wake, sleep, and wakefulness. That is what my simple way to understand as an experimentalist. Therefore, hypothesis to be tested. All prevailing basal substrate could be Turiya state on which all other states play a role. And discrete unmasking and masking gives different states. Thank you very much, and I'm grateful to all my students, not for this model of consciousness. That is my way of thinking, but the experimentalist and whatever a few slides I showed, on the left side, these are the people who have finished their PhDs and wherever they are, including professors in UCLA or JNU or anywhere. And these are still working. We work from behavior to cell to molecule to mathematical modeling to cell culture to behavior. Thank you very much. I will appreciate any questions.
Thank you very much for this excellent talk and about the brain, the neurons, and REM and non-REM sleep, and the brain waves. It's such a complex system, such a nonlinear complex system, and he's done so much remarkable work on these and brought in the idea of consciousness into it and has given it some definition of what consciousness is about through the Turiya state, if I am not mistaken. I probably got it right. So that reminds me, I think it occurs in the Mandukya Upanishad, right? In the 4 states. Yeah. So you are realizing all those things experimentally and by modern techniques. Thank you very much. It's a very thought-provoking talk. I will now request Miss Pooja Dabral to give her talk. She's an assistant professor, Department of Buddhist and Tibetan Studies at Namgyal Institute of Tibetology, Gangtok, Sikkim. A doctoral research topic is Nagarjuna's philosophy of emptiness and J. Tsongkhapa's exposition. Descent in two prolific periods. She has teaching and research experience with a range of institutions, including the University of Delhi and JNU. Ms. Dabral.
Good evening, everyone. Thank you, Chairperson. I wish to start by thanking the organizers, Chopar Somling, Buddhist Center, Tibet House, and Indian Institute of World Culture for giving us this opportunity to take part in this multidisciplinary conference and be able to share our ideas and interact with each other. So thank you very much for that. So the topic of my talk is non-duality and individuation in Buddhist philosophy. Sounds very technical, but I'll try my best to make it simple for you. So there are two, as you can see, there are two parts in my presentation, non-locality and individuation. I would like to deal with the individuation part first. So in philosophy, individuation functions as a principle that differentiates one object as different from another. Basically, differentiates one object distinct. How? Okay, for example, just to make it simple, for example, how do we see this mic and this water bottle as different from each other? So to explain this, so when this question is explored, different philosophical school, they come up with different ideas and concept to explain this principle of individuation. So for example, it will be interesting to know that there are so many Indian philosophical schools who present this concept and they present it differently. So for instance, the Vaisheshik Indian, so the Vaisheshik philosophical school, which is an ancient Indian philosophical school propounded by great philosopher Saint Rishi Kashyap, they talk about, they espouse the phenomena known as substantial entity possession. So this is the technical term they use to explain this principle of individuation, that how two things are seen distinct from each other. And then this substantial entity possession is being refuted in Acharya Dharmakirti, a 7th century great Nalanda Buddhist scholar, a great logician. In his text, in the chapter 2 of the Praman Vartik, in English we call it a commentary on valid cognition. So before and then he doesn't only refute this position but also establishes how in Buddhist system we talk about individuation, this principle of individuation. So before I go into this principle of exclusion as presented in Buddhist tenets by Acharya Dharmakirti's text, I would like to briefly talk about the Vaisheshik Vaisheshik's position of substantial entity known as position. And there is a reason for it, because when I explain this, the way Vaisheshik talk about the substantial entity possession, you will see it will help us to understand the Buddhist position of principle of exclusion even more clearly. So for that reason, I would like to briefly go into their position. Okay, so how Vaisheshika school, they talk about the individuality. So they come up with the idea of substantial entity known as possession. So they make 2 points, which are, they say that this possession, the technical term used by them, they say that it connects or pervades all the parts of an object, one, and secondly, it possesses the parts of the similar kind. So to make these points easier to understand, I'll give you one example. For example, let's say we see this water bottle. Okay, let's say we see this mic, which is constituted of different parts. So Vaisheshik school says that, okay, why do we see this mic as having so unique, distinct identity as a mic and not as a bottle? So when this question is explored, they come up with this idea of possession. So what they say is that this is because of this substantial entity, this substance known as possession, which pervades all the parts of this mic and not of this bottle. And why only mic? Because these parts are of the similar kind. So So they they rely on some substance on the object to be able to explain this individuality of an object. They say if we do not accept this substance known as possession, we cannot distinguish between a mic and a flower. How do we distinguish? So to explain this, they talk about this entity known as entity known as possession. Okay, so next is sorry. So now this being refuted in the chapter 2 by Acharya Dharmakirti in the text known as Pramana Vartik, and it is very interesting to know how it has been refuted and then how he further establishes his own position of individuality. So how it has been refuting, I'll read. This is the verse from Pramana Vartika chapter 2 verse number 90. So the verse says, how can mercury reacting with gold and colors be perceived by the sense consciousness? So Acharya Dharmakirti is actually asking the Vaisheshik's proponent that if I accept the way you say that there is a substantial entity known as possession which pervades all the parts of the mic and not the bottle, then how do you explain these phenomena, the mixing of or the mercury reacting with the gold and the mixing of different colors? How do you so there are so many reasonings given in this same text, but I will go through one or two just to make it clear how it has been refuted and how it leads to absurd consequences if we accept some substance as responsible to explain this individuality of an entity. Okay, so what is being said here? So what he is challenging them, he's saying, okay, if you accept this possession, which you say, okay, possession which pervades the mercury and possession which pervades the gold, they are very different. For you even, they are very different. Do you also see the mercury and you also see the gold as very different from each other? Even Vaisheshiks will agree with this argument. Then now how do you explain? Now you bring these two things together. The moment you bring them together, they immediately react and they give rise to a new compound. So now he is asking them, then how do you explain this phenomena? Because for you, if these two are pervaded by two different substantial entities, then when mixing up, what we see is only one compound. We see that the mercury and the gold immediately react together and it gives rise to a new compound. We don't see two entities. But if we accept your position, which is the substantial phenomena possession, which is different for the mercury and different for the gold, then you should be able to see two entities even when they have reacted. So this is how one refutation is being posed to them. And then secondly, what he said is, okay, for example, this is also very interesting to know. For example, when you look at me, okay, you look at me as a whole, one unit, okay, but I have different parts, like for my hands are there, my legs are there, and then different body parts are there. So now he's saying, he asks Vaisheshik that how would you explain that you see an individual as a distinct entity? You don't see two individuals together as one unit or one whole. You see them as differently. So they will explain on the basis of possession. So now he's saying that because this possession is like now Vaisheshik that say that this possession is like a substance, actually like a thread which connects all the parts together and and allows one to see one entity as one entity. So now the question is being asked, for example, if the same substance is possessing all my body parts, then how do you explain the contradictory movements? For example, if my hand is moving in one direction, all my body parts should move in same direction. So I may not be able to see here and move my hand here. For example, just to explain it, for example, if I tie the 4 pens together very tightly and I move one pen in one direction, all the other 3 pens will also move in the same direction because they are tightly bound. They are bound together tightly. Same way, if we accept this substantial phenomenon known as possession, which is binding all the parts of a similar kind, then how do you explain the contradictory movements? So there are many other reasonings given. So this is how he is refuting this idea of some substance being responsible for the identity of an object as distinct or unique. So now, when this being refuted, so by Acharya Dharmakirti, of course, Vaisheshik proponents will not give up so easily. So they they ask the same question to Acharya Dharmakirti, then in your case, how do you explain this phenomena or this principle of individuality if you don't accept any substance which is responsible for this? So now for this, Acharya Dharmakirti explains the principle of exclusion. So he says, okay, to explain that, okay, so what he says is, for example, what happens is when we see this mic, what he's saying, that it is not that a substance is necessary for you to see this mic as a mic and distinct from this bottle. This is not because there is some substance known as possession or whatever you call it. It is simply because our mind plays a role. So what he is saying, all this can be easily explained if you bring in the role of the subjective mind. And how, for example, when we see this mic, so what he's saying, when you see this mic, what our mind does is it excludes all other phenomena which are not the mic. So, for example, this bottle. So by excluding all these phenomena which are not the mic, our mind sees this mic as having a unique, distinct identity as mic and not as a bottle. So this exclusion, this function of exclusion is not because of something from the substance or from the object. It is purely done through your subjective mind. And if you don't accept the role of the subjective mind, you cannot explain how things are seen distinctly or having unique identity. So this is known as the principle of exclusion as presented by Acharya Dharmakirti in Pramana Vartika. Next, I would like to okay, so now within Buddhist tenets there are 4 Buddhist schools, and then they all accept this principle of exclusion to explain how things have unique identity. Now within Buddhist tenets we have highest Buddhist schools known as Prasangika, Madhyamika, and just before this session we had the session with Venerable Geshe-la, and he made my job very easy. So what we learned is that what is the objective individuality of the object. And then we learn this kind of a formula that emptiness of objective individuality is the individuality of the object, or in his words, the emptiness of the objective what was the word he was using? Yeah, objectivity, emptiness of the objectivity of the object is the objectivity of the object. So in other words, we can put it like this: emptiness of the objective individuality is the objective individuality of the object. Pardon me for this. Emptiness of objective individuality is the objective individuality of the object. So he gave the example of water, and I'll use the same so that it becomes even more easier to understand. So what we learned is that, for example, when we are very thirsty and look at this water, so we see this water and it gives a sense of appeal to us. It gives us a pleasant feeling. But when we see the same water through electron microscope, we don't see water. We see just bunch of molecules. Now, so which one is the correct reality? Both perceptions are correct. Nobody can deny that when you see it through electron microscope, you do not see water, and when you see it through naked eyes, you see water. So then now both perceptions are correct and both are the realities. Now the question arises, now what is more important here to ask is, now if we see the object, if the same object is seen differently through 2 different perceptions or through 2 different frame of reference, then the question arises, what is the real identity or real individuality of the water, of this object? So when this question is asked, the subtlest version of the real identity or real individuality is explained by Prasangika Madhyamika school, the highest Buddhist tenet, in the form of emptiness of the objective individuality is the objective individuality of the object. The very fact that when we see it through naked eyes, we see it water, and when we see it through electron microscope, we see it as just bunch of molecules. It is a proof that from the object there is no individuality, fixed individuality of the object from the object's own side. It is sheer independence or your subjective mind or your perception. You see the object, and that is seen as the individuality on the conventional level. For example, if you are thirsty and you see it through your naked eyes, you will see it as water and you will enjoy it as water. Whereas if you use electron microscope, whatever you do, even if you don't like, you will see it as bunch of molecules. So this is on the conventional level, and because we have different frame of reference, different perceptions, the individuality is different on that level. But then when the question is asked, if this is the reality, that sheer independence on your subjective mind, the individuality of an object is determined, then what is the real identity of this object? Then Prasangika Madhyamika says that there is the lack of objective individuality, that this object lack any objective individuality. This is the objective, this is the real identity of this object. So this is the subtlest version of the objective individuality we learn from Prasangika Madhyamika. Now the next is, and it will take us to the second part of my presentation, which is non-locality in Buddhist philosophy. So just to make it very simple, non-locality in Buddhist philosophy, for example, non-locality in quantum world, we learn that, that different separate entities in the universe, they kind of, even when separated by large distances, they are connected. They are actually potentially connected to each other in an intimate and immediate way. So how this concept translates into the Buddhist philosophy is, for example, let's say in the form of mutual dependency or interconnectedness. Let's say if there is only one tree in CKSL, let's say there is only, in this universe, there is only one tree which is in the CKSL, Chokar Sumling Center. Then if I ask you, is this a nearer tree or a farther away tree? Then what would be your answer? That it makes no sense. When there is only one tree in this universe, thank you. When there is only one tree in this universe, to talk about it being a nearer tree and farther away tree does not make any sense. Only when somebody introduces another tree in this universe, let's say next to Bengaluru airport, and then if I ask you which one is the, now whether the CKSL tree is a nearer tree or the farther away tree, thank you, farther away tree, your answer would be that it's a nearer tree. So in relation, so now from this we can see that the moment second tree was introduced in some area far away from CKSL, the same tree which was not the nearer tree becomes a nearer tree. And we get the impression that something has changed in the CKSL tree. Do we get this impression? Yes. That earlier, yesterday, it was just a tree. Now, today it has become a nearer tree. So something has changed in the CKSL tree. But the fact is nothing has changed in the CKSL tree. It's just when you introduce the another tree in another area, the same CKSL tree becomes simultaneously at the same time it becomes its individuality changes to a nearer tree. So now this is how they are mutually connected and mutually related to each other. Now just to, this sounds very simple, but to understand this mechanism, what is more important here to say is that to understand that how when something else is introduced, the other thing changes its individuality, or their individuality and identity are actually mutually related. Just 2 minutes, sir. Mutually related. From this we need to understand that this is not possible. This phenomena or this relative relation, this relationship in relative terms, we cannot talk about all these conventions if we accept things to have any objective individuality. For example, if this tree, if the earlier tree was nearer tree, or it being a nearer tree was its objective individuality, then whatever you do, whether you introduce a tree or you don't introduce a tree, it should always be a nearer tree. The very fact its individuality changes when the moment you introduce another tree in some other area, it is a proof that the objects lack any objective individuality. It's sheer independence or your subjective mind or frame of reference, the individuality of the object makes sense. With this I conclude. Thank you.
Thank you. So, the final talk of this session will be given by Dr. Anil Choji. He studied MSc Physics from IIT Madras and did his PhD at the University of Texas, Austin, with none other than Professor E.C.G. Sudarshan on open quantum systems and quantum information. He was a postdoc at the University of New Mexico, working in the Information Physics group with Professor Carlton Caves, another great name. Anil took up an assistant professor position at the Indian Institute of Science, Education and Research in Thiruvananthapuram in June 2009. He was appointed as associate professor in the School of Physics at ISA TVM in September 2014. He has over 50 publications to his name, and his research interests include quantum information theory, precision measurements, and open quantum dynamics. Dr. Choji.
Okay, so thank you, Professor Koch, for the very kind introduction, and thank you to the organizers for having me over here in this fascinating discussion, to say the least. To add to the good fortune, I was fortunate to at lunch to share the table with very learned and experienced women and men. And during the course of the conversation, there was a mention of the importance of science students learning literature and language. That got me thinking that we have heard statements in the morning regarding whether that nobody really probably understands quantum mechanics, or if you understand quantum mechanics, you are likely to be shocked. So it got me thinking, probably what we don't really have fully evolved is the right kind of language that can describe in normal terms the phenomena that are quite prevalent, common, and experimentally verifiable in quantum physics. Of course, I risk contradicting some great people like Richard Feynman in saying that, but with humility, one would say that maybe that is true. So, my part of the idea today here is to talk about quantum superposition and non-locality. And it is this same idea has been already talked about by Professor Usha Devi and Professor Ujjwal Sen earlier in different contexts, but I will talk about it in with some focus on superposition and also about indistinguishability and the emergence of distinguishability in quantum physics. So let's start with the notion of quantum superposition. So let's see. This is probably the wrong direction. Yeah. So let's start with the quantum system, whose property of interest for me for the time being is its position. Okay. Now this object could be interesting in many other regard. It may have a spin, it may have a character, it may have a personality. I don't really care about that. The only thing I'm worried about it is where it is. So as far as I'm concerned, the quantum state of the particle has information regarding the position of the particle, and entwined to it through the Heisenberg's uncertainty principle is that I have to have there are certain constraints on the kind of velocity or momentum that it should carry, and all together, mixed together, all I can really say is that there is a notion of a state of a particle which is complete knowledge as allowed by the rules of quantum mechanics of the property or properties that I am interested in. There are other parts of the description of the state which will talk about other properties. Right now I am ignoring. So one of the tenets of quantum mechanics is that suppose I have this particle that is located there, and it's in a location which I call x1. Now that is a very much understandable concept as far as day-to-day life is concerned. You have got an object that is sitting at a location somewhere. So that's a valid state of the particle. Okay, now we have heard many discussions about what it really means to be there and all that. Let's not worry about all that. Now, another possible state of the particle is that it's sitting in a different location. Okay, that is in the location x2. But what experiment has shown, and one of the fundamental axioms of quantum mechanics is the fact that if you know that there are two states in which your system can sit, in this case there are two locations that it can sit, then what is called as arbitrary superposition of these two states is also an allowed state. It does not say that you are going to always find that particle in this superposition state or anything like that, but it's an allowed state. So if you work hard enough in your lab, you can create a state of the particle in which the particle is at that location and in those locations simultaneously, for a lack of a better word. But the state is one in which you cannot really tell whether it is there or here, but it is everywhere in a sense. So it is spread out. Okay, so that's a notion of a quantum superposition. Now, this is generalized to say that this is not just applicable to position alone. There are other properties like spin of a particle. If a spin can be up and spin can be down, and those are things you can understand, then a state which is a superposition of up and down is also an allowed state, which you could, if you work hard enough in the lab, you can detect it, create it, and do things with it. Right? So there is one corollary to that, another axiom which people have mentioned earlier, which is if you ask that particle a definite question, which is to say, where are you in relation to the positions I have marked out, then it will answer one or the other. Okay, the information that it will give out to you is that I am either at x1 or at x2 if you ask that question. If you ask the question, are you at x1 or x2? Now, if you can also ask a different question that's very difficult to ask in terms of a measurement, which is to say, are you everywhere? And then also there is a specific sense in which it will tell you that I am indeed everywhere. Well, let's not get into that complication right now. Now, in the level of quantum physics, this is probably the level of communicating it to a audience that's non-specialist, this is not an easy task to do, to communicate this idea in its entirety. But superposition is a common phenomena in the natural world. For example, waves always superpose. Okay, if I am talking here and one of you talk here, talk in the audience, then the waves we are producing are sound waves. And they will travel in different directions, and when they pass each other, when they are co-located at the same position, they will add up or subtract from each other or modulate each other in an appropriate way. Anybody who has played a guitar or violin or something knows this quite well, because when you're tuning a guitar or a violin against another violin, you know that the point you have to stop is where suddenly you start hearing new notes. The sound going up and down, what are called beating of the waves. Okay, that is a consequence of superposition, and the point you have to stop is the instant where the beating stops. Okay, what it is telling you is that then the waves that are there produced by the two violins are exactly of the same kind, and they are adding up together. Okay, they can also be of a nature that they can cancel each other out, which is what we use in noise cancelling headphones. Okay, the noise that is coming from outside is cancelled by other waves that are produced by the headphone itself very close to the ear. So those noise waves never comes to you because it's cancelled out. And the beating phenomena that I talked about is when two waves of similar frequency come together, its size goes up and down. So you got this wow, wow, wow kind of beating thing when the two frequencies are close to each other but not exactly the same, and you can detect that. So waves can superpose. Superposition of waves is a known thing, but when you talk about superposition of states of particles, things get complicated, as we just discussed, where things are what you thought is here, what you thought is there, but it can be everywhere. Okay? Now, just as an aside, actually in the case of people that you talk to, this is not very strange thing, right? In general, people are just sitting there listening or sleeping or whatnot. But you also know that there are states of people wherein, right, they could be happy, okay, and they could be sad also. These are known states of the person. But in general, a person is not in either of the two states. He is somewhere in between. Maybe slightly happy, maybe very happy, slightly sad. And you also know that if you ask a direct question, are you happy or sad? Typically, you will elicit a direct response, wherein the state of the person in quantum mechanical languages collapses into either happy or sad, because he or she is forced to answer, I am happy or I am sad, right? That has to happen. But somebody who is more clever and erudite may give a more qualified answer, saying that, well, okay, what do you mean by happy and sad? Then you are kind of in great difficulty to answer. But so it's not something that is alien to you as human beings, this notion that it could be both, right? Because that's something what you are most of the time. So that's just an analogy. And incidentally, this was a play that I got to see recently, maybe 2 days back. It's a very interesting play. It's called Copenhagen, which tries to connect the notions of quantum physics with the intrinsic uncertainties that you face when you try to gauge the intentions and the ideas and the mood of somebody else. So this play is about a historic event wherein Niels Bohr, who is a famous Danish physicist, gets a visit from Werner Heisenberg, who is a German physicist, in 1941 during the height of the Second World War. Now, Bohr and Heisenberg were separated for a while because Bohr is half Jew and he is in German-occupied Denmark at that time. So while Heisenberg is in Berlin and presumably working for Hitler in developing an atom bomb. And for some reason, Bohr, who is Heisenberg, who is Bohr's one of favorite assistants and students and proteges, requests a meeting with Bohr. And neither of the two persons are sure about why the other is coming to see them or what the intention is. And this play explores the different possibilities within the background of the uncertainty principle that Heisenberg himself had proposed. So this is just an aside. So it is so this parallel between the human state of mind and some of the notions in quantum mechanics is very cleverly brought out by the playwright Michael Frayn in this play. So so that's just an aside. Okay, so now we had happy people and sad people, but then we have got two people. This is what Professor Ujjwal actually talked about. So when you got two people, you can have these four possible states in classical physics. Both can be happy, both can be sad, one is happy, one is sad, and so on. Assuming that we are asking them questions and saying, allowing them only to be happy or sad and nothing in between. Let's not worry about that. But then in quantum mechanics, these are four possible states of the system. Therefore, right, this state is also possible. Because that's a superposition of one two-body state and another two-body state, because if these are well-defined states, superpositions are also allowed. Now you can complicate the matter further, right, and say that, okay, I can put one of the person in Bengaluru and another in Delhi. This is about flowers that Ujjwal talked about. Then we have got an even more difficult scenario, because if you ask a guy in Bengaluru whether he's happy and he says he's happy, then the guy in Delhi has absolutely no choice but to say that he is happy. Right? Because that is the state into which, the entire quantum state is a two-piece state. And I told you before, if you ask a question of a quantum state, it has to collapse into one of them. Now, since you asked one guy and he said he's happy, and the state in which he is happy is this one, the entire thing has to collapse into that. Therefore, the guy in Delhi also has to be happy. Right? No free will probably. Right? There is no choice there. Right? So this is the conundrum of quantum entanglement, which expands the notion of non-locality in quantum physics by a further degree. Thankfully, people are probably not quantum objects, but as mentioned by the previous speakers, couple of them, if ultimately your happiness is going to be determined by the orientation of a single molecule in a single neuron, hypothetically, then this can be true. Because those molecules are quantum objects, they could be entangled in this sense. And if those molecules in turn are the ones actually providing happiness or sadness or determining happiness and sadness to you, then this can possibly be true. But that's taking things to a ridiculous extent. We thankfully know that that's not the case. A single neuron is not going to determine your state of mind. It's much more complicated than that. Okay, so that's a notion of quantum entanglement, which is, and definitely Einstein was not comfortable about this. So I'm right. So this is just another interlude, another nice print by M.C. Escher, which kind of illustrates the way the sort of inseparable and probably classically logical connection between these two entities. Okay. So, right. Now comes the next thing. Classical particles are always distinguishable by definition. These two things can be made identical by painting them both green and making the sizes exactly the same and all that. But as far as classical particles, ultimately you can say that they are distinguishable because they are at two different places. Okay, there is always distinguishability in classical physics. So there is always identity in classical physics. But the fact that these two particles cannot occupy that last resort, the fact that they cannot occupy the same position, otherwise being all identical, that is lost when you go to quantum physics, because quantum particles are described by states which are in turn extended objects which are both wave-like and particle-like, what are called wave functions. If I got a wave function of particle 1 there and 2 here, I can distinguish them because they are in two different locations. But two quantum particles could be having, and in this case also I can tell, one is on the right, one is on the left. Okay, but quantum particle wave functions can start overlapping. And in that scenario, if both the particles are identical in all respects, all other respects, then I don't know which particle is associated with the left bump and which is associated with the right bump. So what it is turns out is that fundamental particles are by definition indistinguishable. They do not carry any tag. There is no notion of my electron and your electron. They're just electrons. Okay, because and that partly comes up because quantum states are extended objects which can overlap. So an electron is a particle with these properties. That is it. Any particle which has this much mass, this much charge, this much spin, this much lepton number is an electron. Period. Okay, this is a picture that I showed in my previous talk in a similar thing, but I'm not going to repeat what that means because of lack of time. But the point is that electrons are indistinguishable. Okay, and protons are indistinguishable, quarks are indistinguishable, photons are indistinguishable. There is no notion of identity for them. There is no notion of my electron, your electron, my photon, your photon, none of that. Because there is no property that you can attach which will distinguish. And it has experimental consequences, which are, for example, the so-called Pauli exclusion principle, which is underlying the structure of atoms as we see it. So indistinguishability rather than distinguishability is giving structure to the universe. Okay, if they were distinguishable, then the chemistry that as we know will not exist. Okay. So then the question is, and another case where we actually see a consequence of indistinguishability of fundamental particles, a fundamental indistinguishability of fundamental particles, the so-called Bose Condensate, first proposed by Bose. But then there is a notion of emergence of distinguishability when things get more complicated. Two atoms of hydrogen are identical and they are indistinguishable. But hydrogen atoms are composite things. It has an electron and a proton. And furthermore, the electron can now start occupying different internal states. They can be in a ground state, an excited state, and so on. Therefore, possibility for additional labels start showing up. And this definitely has So the configurational degrees of freedom will give you labels that will start telling you a way of calling that hydrogen atom yours and the other hydrogen atom theirs, because mine is excited, yours is not. Right? If they are both not excited, they're identical, you cannot tell which is which. Okay? And then you make things more complicated. Get into a complicated molecule which can have different shapes. Same molecule, different conformations. So more distinguishability. Even more complicated molecules, right? Like the DNA. Then a lot of distinguishability coming from the interrelationship between the components which are indistinguishable that make them up. Sort of parallels to the ideas that we have heard from Buddhist philosophy about the emergence of distinguishability because of the interrelationship, in the absence of which there is nothing. Okay, without those interrelationships. So these are slightly out of a limb. As a physicist, these are speculations, but one would say there are parallels you can draw between these philosophical constructs and these ideas there. So, but these are not mathematically proven, because ultimately that's a language that physicists would be interested in. So these are speculations at best from my side. Okay, and right. So just to go forward, this has still not answered the full question. We have only answered the emergence of distinguishability. There is the notion of emergence of classicality. Okay, that is still unaddressed. Distinguishable doesn't mean classical. Distinguishable particles can still show wave-like behavior and be very quantum. So that's the second question. Okay, right. So how does classicality emerge? We have talked about the Ushadi, we talked about the Schrodinger's cat earlier. Now when does the cat which is in a superposition of dead and not dead actually become dead or dead? What does it take? One of the interesting ideas coming out recently mathematically is the notion of quantum Darwinism. Okay, wherein if it says that the information about the state of the system, if it gets imprinted in many other systems around it, so that looking at the things around, you can deduce what the system of interest is doing, then that system of interest could be considered classical. Okay. At that point, it has lost its quantum non-locality, indistinguishability, etc. And information about it has gone around to many systems around. And just by intercepting those systems, you can actually decide whether so that will give you a quantitative idea of whether the particle is classical or a notion of emergence of classicality. And this is another picture, but this has so it's characterized by broadcasting of information. Again, speculatively, while reading about things about for this conference, I came across the notion of what's called the global workspace theory of consciousness. Okay, in which case there is a central entity which seems to be broadcasting to all the neurons and processing the kind of information that we think is classical. Okay, things that we understand. But these are the amount of information processed by this entity is very small compared to the total information that could reside in a complicated system like the brain. So these may be speculatively representing, so consciousness may be representing those processes within the brain which has come to a level wherein it can be imprinted on many things around, therefore can be considered classical. Okay, and you can build on this idea further, and probably the religious and philosophical and literature and art, what it does, okay, is sort of the reverse, that it makes you process information classically within this so-called workspace, which in turn communicates to the other parts of your brain which you are not consciously aware of, and tempers it so that it doesn't feedback later at a later time things that are troublesome to you, negative to you, and so on. Right? This is something I, in a sense, hear every day from my better off when she tells you that you're spoiling your kids by letting them play video games. Because I know for a fact that this is going to affect their behavior at a later time or immediately. So, right, you have to give them the wise stuff and the good stuff. So that's all I have to say about. Thank you for your.
Thank you very much, Anil, for an excellent talk. I must apologize to Pooja for not having said anything about her talk. To forget is an old man's privilege. So let me very briefly recollect what she said. I mean, basically, she talked about how do you distinguish objects. And there is the old Indian Vaisheshika system where they talk of possession of something, and that was challenged in the Buddhist system by Dharmakirti, where they bring in the idea of exclusivity. And then she went on with other things which Misha Dandulji had already talked about, which was about emptiness, and the emptiness being the essence of everything. Finally, she talked about non-locality, but there I think I have a question which we can discuss later on. So the kind of non-locality which she was mentioning is not exactly the non-locality that we talk about in quantum physics, but we can discuss this later. As far as Anil's talk is concerned, it's extremely stimulating. He's gone through the very basic concepts of quantum superposition, entanglement, distinguishability and indistinguishability, and finally the emergence of the so-called classical world, which remains a problem. What he said very correctly and very perceptively is that you can have emergence of distinguishability, but that does not necessarily prove that you have got classicality. So that still remains an open problem, and he's finally brought in even consciousness and the famous Copenhagen play and all these things. Professor was asking me if they can do such plays abroad, why can't we do it in India? Okay, that is my answer is that is the state we are in today. It's a reflection of what we are today. Anyway, it's been, let me thank all the three speakers for your excellent talks. Pooja was particularly very clear in what she was saying. And, so thank you very much. Indeed, I've told this time only for 2 short questions. Those 2, only those 2, please. Yeah.
Indistinguishability is what allows us to have different elements. Is that what you mentioned?
Yes.
Could you explain further on that? And that seems to be kind of at some level similar to what Pooja was mentioning about the uniqueness or the individuality is the lack of substance. I mean, is that of the emptiness being the essence. So if you can probably elaborate on your point.
Okay, so that idea is quite simple, which is that when you put together 2 indistinguishable particles, there are 2 possible things that the joint wave function of the 2 particles can do. And that has to do with the dimensionality of space and various other ideas. But it goes by, what it is that if you exchange the 2 particles, since they are indistinguishable, as far as you are concerned, the state of the system really does not change. should not change because they're indistinguishable particles. You just exchange the two and you don't know about it. But quantum mechanics allows you for the possibility that the wave function of the pair of particles can pick up what is a minus sign. Because what is observable is only the square of the wave function. So whether you square -1 or +1, you still get 1. That little thing tells you that there are certain kind of particles whose wave function goes to minus of itself. Those kind of particles cannot occupy the same state. Because if they are both in the same state and things go minus, then the only number that is minus of itself is 0. So then that state is a null state, it doesn't exist. Therefore, electrons in an atom cannot exist. If you have got 2 electrons in an atom, say helium atom, they cannot go sit in exactly the same state. If they could, what will happen is that all the electrons in uranium will go and sit in the ground state. All the electrons in gold will go and sit in the ground state. But since they cannot, there is an arrangement of electrons which leads to different chemical properties for different elements with different numbers of electrons, because the way it is filled is different. They cannot all go sit in the same state. Right? That's the notion of.
Yeah. Second question, please. The last question.
Good afternoon. My question is to Professor Anil Malik. So my question is, if I speak from a perspective of a science student and a biology student, you said that consciousness is a medium through where neurons, action potential, and neuron firing take place, where information is processed. If that is the case, what is the constituent of consciousness? We can speak. If we talk about the blood constituent, if we say something like plasma, red RBC. So if that is the medium of information, then consciousness should have something, should constitute something, right? So what is that? And my second question is.
Only one question.
Okay.
Well, I think this is a matter of understanding. What I was saying is, since you are a biology student and you are questioning from that perspective, what I said, neurons have action potential. But action potential is when it crosses threshold, and therefore all or none law, which was necessary in evolution to carry discrete information. Until then, for every cell there is transmembrane potential, and that would have its own slow potential. So what you are talking about, blood and plasma and all, they will be carrying molecules which have existence, and that will have shape, size, and that will give specificity. Here the waveform does not have specificity. Difference is that therefore when the nervous system has evolved, it has evolved the synapses. Neuronal system, electrical signaling is for faster communication, but it does not give specificity. That is because of the chemicals which is at the synapse and the neurohormones. So that's the second question. But what I mean is, if the action potential has to propagate, that is propagating in structure, space and shape, that is through the axons, that is the medium. But if it has to go through space where this is not there, how would it cover? Which is what you have, the dipole system, which would cover as induced current, that would be going through this. That is, therefore you need some long wave pattern, which I mean, the way I would describe it, it is the non-local function. When that part is discretely covered, becomes a localized, that is wakefulness. Or another way, little bit otherwise, that is non-REM sleep. And when other state is coming, these are again discrete. And that is what he was explaining, partially happy, partially unhappy. That is your drowsy state. So these have to be explained, and that we do it by different frequencies. For example, in human EEG, we are talking about alpha waves, which is highly active. Beta wave, highly active, is 25 onwards. When we are talking about drowsy, 11 to 25. Or when we are going to sleep, that is about a theta wave is 3.5 to 7. But when we are going deep sleep, we are going to 0.5 to 3.5. But then there will be in between also. Now for each of these wave pattern, if we can do EMD, then you can have at least 10 IMF in intrinsic mode functions. That is coming even from them. And we are not distinguishing what is a glial waveform and others. What I would think, fundamentally this is coming from the glia, and the way when I saw evolution, the way we understand that is starting from earthworm onwards. Before that, glia is not there. And generally we talk about consciousness in that way. And the more it goes, we say more conscious. But if you have seen at the end, the elephants, they have the multiple 5.6 times glia. That means, are they more conscious? I don't know. I have still more to answer.
Thank you. Thank you, everyone.
Thanks a lot.
Just a minute. Thank you to all the panelists. Now I would like to request the chairperson to felicitate the speaker with Khatak and souvenir. Dr. Anil Choji. Miss Pooja Dabral. Yeah, thank you.
Thank you. Thanks.